My name is Jeffrey Hayward. I work for a company called Automationworks. We're a national company. We do work internationally out of South Africa, in Africa as well. I studied mechatronics at CPUT. I qualified in 2012, I think.
My name is Ongam Stokwe. I'm working for Automationworks. I did BTech Mechatronics at CPUT.
What we do is we supply a solution to a problem for an industry. Primarily food and bev, but we do work for some chemical companies and some maybe more specialist companies as well. The idea is the process control is pretty much all the same. You have a valve and you have a pump and you have a tank, and you need so much level in this tank, so you open this valve and you run a pump. And there's usually some measurement equipment, which would be like a level transmitter or a temperature transmitter, and you use that to have feedback from the outside world. And then you'll have the items which you control. You open, you close valves, you turn pumps on and off, and that's how you actuate things in the physical world.
Okay, for drawings, we actually work with AutoCAD. But before we go to AutoCAD, we use Visio. This is where we show the client. This is how we, because most of our clients, they're not engineers. So we need to show them something they can get a clear picture of it. Okay, this is the picture of the drawings that I'm working on now. This is what we presented to them. This is where you'll see all the valves, all the sensors, and all the PLCs. What this is here, it's what will be in real life. But from there, then we have to work on the AutoCAD. AutoCAD, it's more for the engineers they'll be using when we explain to the engineers where our sensors will be, what kind of sensor we'll be using, what pumps we'll be using, how many wires do. That's where we go into details of the project.
So essentially what we'll do is we'll go to a client who says, okay, we're having a problem, our mix plant isn't putting the throughput that we need to up our production, how can we do it? And we'll go, okay, right, let's just have a look at your system. You've got a guy there, he's just pushing a button, and then he's walking and picking something up and he has to pour it in. And then you've got another guy who's putting lids on. And what we can do for you is we automate that process there, where you have a bulk tank and it automatically feeds through the right amount, so you don't have to have a guy tipping something in. So it's repeatable, it's a faster process, and you'll have less loss and wastage. And the lidding system, we've got this machine that we'll design that takes the lid, puts it on and screws it down, and that saves a lot of time, because that can be done in 1 second versus a 2-minute job of a guy hitting a lid down with a hammer on a paint tin or something like that.
There's a company called Africa. We used to do maintenance for them every Friday. So I'll usually go to with Shandin, because I don't have a lot of experience with automation companies. So because, as I said, this is the first one. So when I go out to the industry, I usually go with him or Jeffrey. They will guide me with my thinking of what is happening in the problem, how I should solve the problem. So there will be more, because they have the experience and they know how the PLC, the sensors, the pumps, how they all come together. They will be able to guide me. Not actually do it for me, but guide me or way how to think about the problem.
Okay, so essentially what design work entails is taking off-the-shelf components, parts, items from our suppliers, and putting them together in such a way that it suits the solution specification. It's not a case of inventing a new pump. It's a case of going to the manuals, reading the technical documentation, and specifying a pump for the correct flow rate and application that you want to use it. Likewise, for the pipes and the valves and all of your sensors, you essentially are reading through technical documentation and specifying the correct part using engineering principles, more than designing a new part that's going to fit into this design. When we work from first principles, we end up in a position where we say, okay, we need to get a throughput to a filler of 20,000 liters an hour. And therefore we have to work our pipe diameters and our pump sizing on the supply to this filler to that specific size. So then you'd go to the fluid dynamic calculations and you'll actually say, okay, right, at such a nominal diameter pipe, what is the maximum flow rate, and you'll have to work everything out. So essentially it's not guesswork, it's not, oh, this might work. You're actually working it from the grounding of engineering principles and equations.
Okay, typically just a usual day. Okay, when I walk in here, I first look at what I didn't do last time, what I didn't finish last time. I discuss with Jeffrey, is there any new changes? Because there's almost daily changes. Okay, there's changes in this drawing or that drawing because there's different drawings. So he will tell me what he thinks should be changed, or what he thinks might be changed, or what he thinks I might include. I do that. If I'm done with the drawings, I also go do the SCADA drawings, which is done on those computers there. That's where I will look at the SCADA. Okay, what needs to be done for the project? What more must be done? If I'm done with that, then I can go help the guys, Sandine or Jeffrey, with the PLC. What can I help in there? What should I do there?
So typically, if we're not working in the office and we have an installation which will be on site, it goes through a couple of phases. Because we are primarily an automation company, the bulk of our work is either electrical cabling or programming. We outsource a lot of the mechanical work, so the welding and the fitting of pipes. So essentially, an installation will involve the project work which goes on before, and then when we get to site, you pull the cables, you connect up all your instrumentation, you commission it, you make sure that the controller is receiving the inputs, and you test the outputs that they turn on. And then once you've got that stage finished, then you do your software commissioning, where once you've got everything that works, then you start running through your code, and you'll say, okay, run this line of code. Does it work? Does that turn on? Yes. Okay, sign that off. And literally, it's a step-by-step process whereby you end up going through all of the code that you've written, testing it, making sure it does what it should, creating faults in the code just to see, or in the field, to see if the code handles the fault correctly. Because literally anyone can write software. Anyone can tell an output to come on or an input to do something. However, that's not the importance of automation. The importance of automation is making very sure that when something happens that shouldn't, that the code handles that correctly. I'm a firm believer in upskilling. So essentially, where you've got 30 people who are essentially serving no real purpose in a process except for manpower, whereby if you upskill them to be operators and controllers of the system, it's certainly better than the menial task of screwing caps on a toothpaste tube, which I don't think, that's not a very dignified job in the first place. You know, I'm firmly a believer in giving people dignified jobs rather than inventing jobs just for the sake of people to have a job. I think the things I love about the job are the spontaneity of it all, the fact that 2 minutes before now I could be working on a spreadsheet for specifying gland and cable sizes, and I could be driving out to a client who has a breakdown and needs something fixing in an emergency. I think also the fact that even the fact that what we do is we have a holistic approach. We do turnkey projects. So today I'm doing the gland and cable sizes. Tomorrow I'm designing panels. The next day I'm doing software. The next day I'm commissioning. There's certainly not a fixed structure to the days. There's a fixed structure to the project, and that involves this much of doing something, this much of doing something, and this much of doing something else. And essentially that brings a lot of diversity to all of the projects and your daily routine.
Most challenging is that, okay, when you're doing drawings, first of all you want to be clear, and they must be accurate. You must be focused on those things. Therefore, you must pay a lot of attention to details. So sometimes you'll be working on a drawing for like a month, making sure everything. Then the client will call and say, we've done some new calculations. Now we have a lot of changes. We need less sensors, more pumps. Therefore, you have to change everything. You can't complain. You have to again start over again and make sure what you're doing is still accurate and still right.
Most challenging about the job, firstly, on the day-to-day mundane routines can sometimes become a little bit boring. You live for the rush of the installation and the commissioning, but at the same time the installation and commissioning also means long periods of work. If you're working for a factory that has a deadline, typically most factories in South Africa, if it's a big factory, they have to run 24/7. They've written their capex budget off over the next 20 years of that machine running non-stop. So every time they stop, that's costing them a lot of money, which means that if you have an installation, you have no time to finish it, to commission it and install it, which means working long hours. So it's catch-22. You love it because that's the part that's exciting, watching the machine start for the first time. But then it's also a case of very long hours, very hard work, and it's sometimes a thankless task because the guys who should be saying, "Thanks so much for automating our factory," are going, "Why isn't it done yet? You've got 2 more minutes," which can be a bit frustrating.
I would say you should fall in love in questioning things, how things work, puzzling things out at a young age if you can. Don't just go to Google and say, how does this work? First think about it. You should use Google as your guidance. Okay, correcting yourself. Okay, I was wrong there. Before you actually go to Google, just first think about it. How does a car work? What is driving it? What happens when I start a car? What happens? Okay, think about that process. Then from there, you go to Google. Then you correct, I was wrong there. Then you think about why was I wrong? So you should forever be thinking about stuff like that, questioning everything.
My advice for students who want to study and get into the field of automation, I studied mechatronics and I thoroughly believe that subject covers a lot of the important groundwork for getting into a automation field of work. I think that personally, I can see how it's shaped the way that I think and the way I approach problems as an individual who maybe would have tackled certain things very differently before doing the course. So also, I'd say that you have to be able to handle a lot of or a stressful environment where whilst everything may not always go as planned, you still have to come up with solutions to those problems, and that can be stressful if you let it. Typically, if I don't know the answer offhand, Google is your friend. Typically, you will find any question that you can think of available on the internet somewhere. Someone has thought of it, someone has asked it, someone has answered it. So you will be able to find some form of answer as to how do you do something. And if you don't know, you can always phone a friend and ask. I've got quite a few friends who I phone on a regular basis, electrical engineers, a material scientist, and if I don't know the answer, I'll ask someone who does, and I'll take the principles that they give to me and then apply those.